Okay, so now we're going to take the simple power rule that we've been using and extend it to the general power rule. So as a refresher, the simple power rule says the integral of x to the n dx is x to the n plus 1 divided by n plus 1 plus c. So now the general power rule says the integral of u to the n du is u to the n plus 1 over n plus 1 plus c, but what's different now is u is a function. So for all of these problems in numbers 1, 2, 3, and 4, we have to first identify a factor of u from the integrand, that's the part you're taking the integral of, that is raised to a power. Then we have to show that its derivative is also a factor of the integrand. So here's how that works. For number 1a, we're looking at this. We have 3x minus 1 to the 4th. You could do 3x minus 1 times 3x minus 1 times 3x minus 1 times 3x minus 1, and then distribute a 3 from this coefficient to every term. But that's a lot of algebra and not necessary. What we could do is say that u is 3x minus 1. And then we're going to find the derivative of u. So du over dx is 3. So now we're going to use substitution. In this problem, I'm going to rewrite the integral. And then instead of 3x minus 1 to the 4th here, I'm going to make that u to the 4th. And then we're left with 3 dx. So I'm going to come to the derivative part here, and I want to match 3 dx with something from this. So if I multiply both sides by dx, we get that du is 3 dx. So now we can substitute in for this part. And I replaced the 3 dx with du. Because our integral is in all the same derivative of u, I can now take the antiderivative. But then as one last step, we have to substitute back in our original function. And don't forget the plus c. Okay, so now for b, to decide which piece of that integrand I'm going to make u, I'm going to think to myself, if I take the derivative of one of them, will I get the other? So for example, the derivative of 2x plus 1 is 2. That is not x squared plus x. But if we take the derivative of x squared plus x, will we get 2x plus 1? And we do. So now I've chosen the correct u, and I can substitute u in for this piece. From here, I need to match 2x plus 1 dx, and I can do that if we multiply dx to this side. So now our integral is u du. So using the power rule, and then as a last step, I'm going to substitute back in the function I said was u. Plus c. So now for c, choosing my u function, the derivative of 3x squared will not get me x to the third minus 2. But if I take the derivative of x to the third minus 2, I get 3x squared. So now rewriting the integral, this function is my u. Then I'm left with 3x squared dx. I can multiply the dx to this side, and now I match the remaining part of my integrand. I can substitute again. And I can replace the 3x squared dx with du here. Now I'm going to add 1 to my exponent, divided by the exponent. We have to substitute back in the original u function, and I'm going to multiply by the reciprocal of the denominator. So now the original u was x to the third minus 2. Okay, and last but not least for d, the u is going to be 1 minus 2x squared, because then the derivative is negative 4x. So substituting into my integral, I have negative 4x over u dx. And then instead of leaving it in a fraction like that, I'm going to make it 1 over u. Oh, I'm sorry, it's squared here. 1 over u squared times negative 4x dx. Because then if I multiply this dx to this side, we can replace the negative 4x dx with du. And now to take the antiderivative, we have to rewrite this fraction so that it's not a fraction, and instead we're going to use a negative exponent. So now the antiderivative is u to the negative 1 over negative 1 plus c, and then let's substitute back in our function, but we don't want to leave a negative exponent in our answer. So this negative 1 here, I can use this negative as a coefficient of the whole fraction, and that's our answer. So now for number 2, we're going to do the same thing. We have to pick a part of this function to be u. And I'm not going to choose x because the derivative of x is just 1. So let's choose this inside function. So now we have the integral of u squared x dx. And then let's find the derivative of u. That's negative 8x. So what we have to match is x dx from our derivative piece here. So I'm going to multiply dx to the right. So du equals negative 8x dx. And then I'm going to divide by the negative 8. So what we have is du over negative 8 equals x dx. So now I can replace this x dx with du over negative 8. But I don't like du over negative 8. That's the same thing as having du times negative 1/8. And then because negative 1/8 is a constant, we can move that to the front of our integral. Now we can do the antiderivative. And before I substitute my function back in, I'm going to multiply my denominators. And now as a last step, we can substitute back in what we said our u function was. And that's 3 minus 4x squared. Okay, so for number 3, I'm going to pick that inside piece to be my u again. So now I have the integral of u squared negative 8 dx. But actually, this negative 8 is a constant. So what I'm going to do is I'm going to rewrite it in the front of my integral. So now I need the derivative of u, and I have to substitute in for dx. So I'm going to multiply dx over to here. And divide by negative 8x. So du over negative 8x is dx. So now I have a problem. We still have an x variable when I need to do the antiderivative with respects to u. So I'm stuck. I can't take the antiderivative when I still have this x here. I could go back to this part and isolate x, but that would be a nightmare because we have x squared. So this doesn't work. I can't go any further. We do have an option because the power here is just a squared. It's not a very high power. I could, if I get myself some space, actually multiply out that integrand. So we will FOIL or box method these terms. I didn't give myself enough space. And distribute the negative 8 to everything. Combine like terms. And now we can take the antiderivative of this polynomial. If this power was higher than a squared, where we just multiply it by itself, you could use binomial expansion that you learned in pre-calculus to expand the binomial. But it's a lot of algebra and a lot of work. And that is our answer. Okay, last but not least, we have number 4. I have to pick a u term, and I'm going to use the piece, the binomial that's inside here. So du dx is 3x squared. So rewriting the integral, the 7 is a constant, so that can come to the front. And then I have u to the 1/2, and I'm left with x squared dx. So I'm going to manipulate this so that I get x squared dx. Multiply that to the right. And then I'm going to divide by 3. So we have du over 3 equals x squared dx. But instead of du over 3, I'm going to write it as 1/3 du. Okay, so now we can substitute x squared dx. I can replace it with 1/3 du. And that 1/3 now is a constant, so I can move that to the front of my integral. And I'm going to do 7 times the 1/3. Now we can take the antiderivative. So we're going to add 1 to the exponent over that exponent. But I don't want the fraction in a fraction, so we're going to multiply by the reciprocal of the denominator. We can distribute the 7/3 into this, but we don't actually have to write 7/3 times the constant, because 7/3 times a constant is just another constant, and that plus c represents any constant. So now the last step is we're going to substitute back in for u. And this is our final answer.